Okay, good morning. Hope you guys had a good 3-day weekend. And so let me just go over a few things before we start today's exercise. So I sent you guys an email with a few pieces of information. Okay, so I know some students have had, are still trying to get access to the full version of Excel. And so that's expected to be a problem the first week. And so I just pushed back. Basically, you saw the email, but you have another week to do the first two assignments. Okay, and so if you've already done the assignments for last week, then just you're done with that. But if you haven't, if you need some more time to get Excel and to get caught up, I know some students added late, and so that was a problem as well. But just the only change on the syllabus is that last week's assignments and this week's assignments are all going to be due next Tuesday. So the deadline was extended for the first two assignments, so therefore, like I said in the email, okay, the first four assignments, the two we did last week and the two we did this week, are not officially due until next Tuesday. So your first assignments are due Tuesday, September 15th. So that'll give you guys an extra week in case you added the class late, you're still trying to get Excel, still trying to figure things out, etc. Okay, and so I've been trying to make sure everyone has Excel, and so I checked and it looks like that you can get it, like I said in this email, you can just get it through the university because the University of La Verne has a subscription or whatever, a partnership with Microsoft. And so if you click on the link that I put in the email, it should take you to this page. Alright, and then if you just put in your La Verne email, it should recognize you. Like, I'll show you I'll just put in mine here. Alright, and then obviously you guys will click on I'm a student unless you're a teacher. And then just click sign in. Let's see. Okay, and then when you sign in with your La Verne email, it should take you to this page. And here you have access, see it's through the La Verne portal up here. And so you got Excel, you got PowerPoint, you got Word, you got all these other things. And you can use them online, and you can also just download it, like when you start. So there you go. It's taking a little while here, but so the point is that I'm pretty sure that all students have a free subscription to the student version of Microsoft Office through University of Laverne, and so just click on the link, put in your email address, and this is if you already have Excel, don't worry about it. But if you need to get Office, you can get it through school for free just by doing what I did, and it'll take you here. And then you can even do the just open a desktop app, and it'll put all the software, the program on your desktop. Okay, so if you're still trying to get Excel, the full version, you should be able to do it just like I showed you through that steps, because Laverne has a subscription for Office with Microsoft. So try doing that. If you need Excel still, if you have any questions, or if that doesn't work, let me know. But the good news is it looks like Laverne has or provides free Microsoft Office for all students. So that should work if you're still trying to get Excel. If it doesn't, then shoot me an email or say something, and I'll try to help you later. Okay, so we'll go ahead and get started. So just to summarize, if you just came in, all the last week's assignments and this week's assignments are not due officially until Tuesday, September 15th. And if you need to get Microsoft Office to the school, click on this, put in your email address, and that should work. All right, and so that should hopefully help you guys all have Microsoft Excel and give you guys an extra week to finish the first assignment. All right, so today we are going to do example 2.5, and let's go to the example 2.5 section on Blackboard and get the files for that. All right, so you can open up the golf club demand. This is under example 2.5 on Blackboard. Open up the golf club demand template. That's the Word Excel file. Example 2.5 has the steps and the instructions, and then this has some practice problems that as my solutions, and so we'll do these three things. And so get those open, and then let me read you guys just a little synopsis of today's exercise. All right, so this is example 2.5. So the Lynx Company sells golf clubs at golf outlet stores throughout the U.S., and the company knows that demand for its clubs varies considerably with price. In fact, prices vary over the past 12 months, so we have data on that, and the demand of each price has been observed, and so I'll show you that in the spreadsheet. Golf club demand. All right, so we have corresponding demand when the price of golf clubs is a certain amount, so we'll look at that to do our analysis. And the company wants to estimate the relationship between demand and price. This is like estimating a demand curve for golf clubs for this company, and then use this relationship to answer the following questions. Well, we're gonna find the relationship using some techniques, and then we're gonna see how the optimal price depends on unit cost. And yeah, so let's try to estimate the relationship between price and demand, which is the demand curve for this this company that sells golf clubs, and then we'll try to maximize profit based on that. So let's look at the Excel file. Okay, so here we go. This is the data we have. So we have 12 months of data, months 1 through 12, and then this is the price they charge for golf clubs. So for example, the price was $450. Then that was demanded hundreds, so 4,500 golf clubs were bought at a price of $450, and you see that when the price goes down, more people buy it because it's cheaper and they can afford it, etc. All right, so this is the corresponding price and demand data that we have observed. So we're going to try to use this historical data to estimate what happens to demand when price changes based on the data we observed, and then we can use that to do a little profit maximization problem for this company. Okay, so let's pull up the example 2.5 Word document, the steps. All right, so we're doing kind of an intro. If you've done any type of statistics or regression analysis, any statistics course, you might be familiar with a couple of these concepts. There's a video, optional video on regression, and we'll cover this more later in chapter, I want to say 14. Okay, but yeah, so take a look at that video when you get a chance, and it'll explain more on regression and statistics, and we'll do more of that in the latter chapters. But we're going to use a little bit of this to estimate relationships between price and demand. Okay, so example 2.5, we're estimating how demand changes with price at this hypothetical golf club wholesale company. All right, and we are going to estimate 3 types of equations or possible relationships for this. So all of these will try to estimate when price changes, what happens to demand. So we'll look at a linear type, right? Is this a good estimation? We'll look at a power type, which means that just the relationship is raised to an exponent. And we'll look at an exponential type where the effective price on demand changes exponentially. Okay, so these are the general types of equations. You don't have to memorize these equations or anything, but we're going to estimate 3 different types and see which one is the best fit, or which one fits the data the best, and then we'll use the best one to do like a profit maximization model for this golf club company. All right, so the first thing we do, step 1, is make a scatter plot of demand and price, and just see what it looks like. So let's go to the back to the Excel template. Okay, so here's our price and demand data, and let's make a graph of that, or a scatter plot graph, and see what it looks like. So it's always helpful to observe the data with just on a graphical sense, and see if there might be a relationship. So let's do that. If you want to select all the price data and all the demand data like this, so you can select the range of D3 to C15. Alright, so all of this price and demand data, and we're going to go ahead and make a scatter plot. Okay, click on the Insert tab, and if you have an option for recommended charts, click that. And that's the one we want to scatter. Just hit, choose that and hit OK. Okay, we'll do some formatting, but this is what the graph should look like. All right, so everybody good so far? We got the scatter plot. Okay, so what we're going to do is, so we'll change we'll put in a few labels and formatting, and then we're going to need 3 of these graphs because we're going to do 3 different types of estimations to see which one is the best fit of price and demand. All right, so first you can let's format the pricing data to be currency, so we know which side is we know which axis is the price. So if you just select the prices over here, B4 to B15. And then under the Home tab, you can click on the Format drop-down menu like that, and then Format Cells. All right, and then you can choose Currency. And I think we have whole numbers, so you can choose 0 decimals because it's just going to give you 2 zeros if you don't. And then we'll have the dollar sign to show that the price is in US dollars. All right, and then if you click on the chart, you should be able to get to the plus sign, which has the chart elements, or just get to the chart elements. And all we're trying to do here is add labels for the axes. All right, so if you click on the plus sign for chart elements, and you click on axes titles, there you go. And let's go ahead and call this is price, corresponding to this column over here. Okay, and this one is demand. All right, here's the demand column. All right, so if we got that, the best thing to do, because we need 3 graphs. Since we got this one nice and formatted, we can just copy it and paste it twice, and then we'll do the analysis separately. But if you do this, I'm sorry, could you show how to? Yeah. Okay. Input currency one more time, sure. All right, so to input the currency in the appropriate range you select, you can choose the pricing data here, which is B4 to B15. And then if you're into the Home tab, you should see this Format drop-down menu. Click on that. And click on Format Cells. And then just change the category here to currency. And you can, I just chose 0 decimals with the dollar sign, and the rest of it I left as it is. And that should give you a dollar sign for the pricing data. Okay, great. You're welcome. All right, so if you got that, I'm going to copy this chart. And so to copy, it's Control-C. All right, so that's copied. So just click on the chart and hit Control C. And then click on a spot maybe right here and paste it, and just hit Control V for paste. All right, and then I'm going to paste it one more time because we need 3 of them. And so just click on a spot to the right of the second graph. And hit Control V again to paste it a second time. All right, so we're just trying to get 3 graphs just like that all in a row. And then we're going to do one for each type of equation we're going to estimate. We'll have a linear and a power and an exponential. But for now, we just need the 3 exact copies of the graph so we can work with those. Okay, so if you look at the steps, we're going to do a linear fit in step 2. We're going to do a power fit in step 3, and we're going to do an exponential fit in step 4. And so for now, let's just label the graphs accordingly. So the first one will be linear, the second one will be power, and the third one will be exponential. All right, so if we go back to the spreadsheet, let's just give this one a title. This will be the linear one. The second one, this is the exponential. We can just give it a title. All right, and the third one, actually, which was the, oh yeah, so it's linear, power, and exponential. Okay, so the second one, let's call that power. Okay, and the third one, let's call that exponential. Okay, so you have the same graph 3 times, but this will be the linear, this will be the power, and this will be the exponential. Okay, are we good so far? Okay, let's go back to the Word document, the steps. All right, so we got the scatter plot. We've done step 1. And so let's do, the first thing we'll do, step 2 is a linear fit. what we're going to do is use the trend line tool and find the best fitting straight line. And then we'll choose the option to display the equation on chart. And it'll be, here's the general form. So your equation will look something like this. Y equals some number plus some number times x. Okay, so let's do the linear fit step 2. Go back to the Excel file. All right, so click on the linear graph that you call linear, all right? And then when you click on it, click on the plus sign for chart options or chart elements. And then go down to where it says trend line and click on that arrow right there, like this. And then click on more options. Okay, and when you get here, then you want to select linear. It's probably already selected, and then you want to go down. And you want to choose this option where it says display equation on chart. And then close that. And so you get this equation here, which is for the linear fit, and that's using that trend line option. Okay? All right, so if that works, step 2 is to do it for the power fit. So step 2 is power fit. Step 3 is power fit. Okay, so for the power fit, click on the power fit option for the power fit graph, and then click on the plus sign for chart elements. We're going to do the same steps, except we'll choose power instead of linear. So click on chart elements. Go down where it says trend line and click on that arrow. And then choose more options. Okay, and then choose power for the power fit. And then choose display equation on chart for the equation for that one. All right, and then let's do the one for the power fit. The exponential fit. The next step, whatever it is. Step 4. All right, so if you made it this far, click on the exponential one, and do the same process. Click on the plus sign for chart elements. And click on the arrow after trend line, and then more options. And then here you want to choose exponential, and then you want to, again, display the equation on chart. like that. Okay, so we have a linear with the trend line and the equation. We have the power with the trend line and the equation, and we have the exponential with the trend line and the equation. All right, so everybody following along, do any of those steps repeated? Okay, so what we're trying to do here is see these data points are the actual points from the data, and we're trying to fit an equation or a line to see which one captures the data the best. And so this would be the linear option, this line. This would be the power option, this line. And then this would be the exponential. So it looks like the data points fit better on one of the two curved ones. So it looks like exponential or power are both good options, and we're going to try to figure out which one. The linear doesn't look bad, but the other ones look better. And so the point is now to take the equation estimations and to do a little like error checking and see which ones fit the data better, and then we'll use that option to do the profit model in the next step. Okay, so the next step 5 is to find the parameters, or just to type in the parameters of the best fitting curve. So all you gotta do here is manually enter the parameters. Let's manually enter the parameters of the equations from the scatter plot into column B. Okay, so we're just going to type in the numbers we got from the three equations, and then we'll use those to do the analysis. Alright, so you can see down here where you got the parameters of the best fitting curve. So the intercept, so we're just typing in the parameters from these equations. So the intercept is this number, 211.31, just type that in B19. Okay, I just realized my power graph has two trend lines. Okay, you can fix that just by okay, so if you have two trend lines, I've seen this problem before, just click on the graph again and click on the plus sign and just remove the whole, just uncheck the box. Alright, and that should take away all the trend lines, and just do it one more time. Alright, so uncheck the box, then you have blank, you have no trend line. And then do it again, click on the power, click on chart elements. Go down here, don't click the box, click on this arrow. Click on more options. Yeah, and then power and then display equation on chart. Okay, looks like you got it. Okay, let's go Okay, Kayla, you got the trend lines, and then let's see, can you show how to input the equation in the chart one more time? Yeah, so. Alright, so you just need, when you're doing the trend line, just check on that box. So I'll do it again for the exponential. Alright, so to get the equation, you gotta do it when you do the trend line, or it's like it's an added option. It's like a la carte. So here we go for the exponential, click on it, click on chart elements, and then down here where it says trend line, click on the arrow, and then more options. So this is exponential, click on exponential, and then when you're here, with the format trend line space, parameters, go down, and there's a box that says display equation and chart. You're going to check that here, and then that should do it with the trend line. Okay, you're welcome. All right, so I think if any more questions, just post them or ask them. And so it looks like most of us are caught up. And so what we're doing in the next step was just typing in the parameters from the equations we got. All right, so we left off, we're typing in the parameters of best fitting curves down here. So last step was we put in cell B19, the intercept, which was 211.31. And then the slope, all we're doing is putting in the numbers from this equation. The slope is this number, negative 0.3546. All right, so the intercept in B19 is 211.31, and the slope in B20 is negative 0.3546. All right, now we're going to type in the equations from the power curve. All right, so let's do this. If you click on it's got the decimal format like this. It's easier to see it if you put in the full number. So you can click on the under power. Just click on the little equation and right click it. And there should be an option for format trend line label. Click on that. And just change the category to number. And yeah, you can leave it with the two decimals and the comma separated. All right, so that way we see the number instead of like that E plus 06 there.
Excuse, can you do it again?
Yes. Okay. So yeah, we're just formatting the number format. So let me go back. There we go. All right. So if you got this equation, y equals 6e plus 06x raised to the negative 1.908. Let's just format that to be in a full number format. So just click on the equation and right click it, and you should see format trend line label. Okay, and you want to change it to number. and the default is 2 options with the comma, and you can do that and hit, it should change it for you.
Yes.
Does that work? Yeah, so it should do that. So it should, if you change it to the number with 2 decimals and the comma, and you should get the full number, which is like 5 million. And yeah, instead of the E plus 06 format.
The format code is different. Is that okay?
So the format's different?
Format code.
Format code?
Uh-huh.
Or you mean the formula? So does it say 5, does it say this number?
That's the thing.
Oh, that's okay. As long as you get the number, it doesn't, yeah. So it says 5871064.20.
Thank you.
Okay, you're welcome. All right, and if that worked, we're going to type in these numbers. So this big number is for under the power fit. This is the constant. So 5871064.20. If I can remember that. All right, that number goes here. For the power constant in cell B22, so type in that number, which is 5871. All right, so that goes there. And the exponent is negative 1.91. All right, so that goes there in D23 for the exponent for the power. Just type it in. And our last parameters are for the exponential, so let's see what those are.
Excuse?
Yeah.
Mine, 1.91 is positive. It's not negative.
Here? Or for this, for the equation?
The graph. The graph.
Oh, it's positive?
Yeah.
Does the curve does the curve look like this?
Yeah, same.
It shouldn't. If it's positive, it would be like this. It would go out. What do you call that? Like concave or convex. If it's negative, it's going to look like out inward like this. But if it's positive, your curve would have to go like this. So as long as it's, it might just be like you chose the negative option to be like in parentheses or something. Like it doesn't.
Can you see that?
What?
Can you see my?
Can I see your screen? So I think. I think you might have just chose one of these options. Or maybe it's red or in parentheses. But I think it's negative
I
because.
just open my camera and share my computer.
Oh, let's see. Yeah, I can see it. It's negative because it's shaped in the appropriate way. So I think it's just a formatting. So it's just I think you have it as negative. It just doesn't show the negative number because it has to be if it's shaped that way. Yeah. So just don't worry about that. Just type in when you type it over here in the parameters. Just type in a negative.
So is that
Yeah.
I have to change anything?
No. So just let me go back to. So the only thing you have to change, this is just for display purposes. Make sure right here, in B23, it's negative 1.91. So this is what you have to have a negative 1.91.
So it looks like this one?
I shared my screen again, but yeah, so in B23, just type in manually negative 1.91.
Okay, thank you.
Yeah, you're welcome. Okay, was there another question? All right, so I think all right, we're back on my screen, and everybody can see this. Yeah. Okay, so the final part of this step is to put in the parameters here for the exponential. So the constant here is 466.51. And the exponent is negative 0.005. Alright, so this step you should have all these numbers just typed in over here. Alright, so here's the intercept, here's the slope, here's the constant, here's the exponent for the power, here's the constant for the exponential, and here's the exponent for the exponential. So we'll just all we do is type in the numbers that we got from the general graph. Okay, next step. Okay, we're going to calculate the predicted demands from each equation that we got by using the equation parameters and then the actual data. All right, so these are the numbers we're going to put in, or the equations we're going to put in E19, F19, and G19. All right, so in E19, it's equals $B, $19, plus $B, $20 times B4. Okay, there's your equation. Equals $B, $19, plus $B, $20 times B4, and that goes into B19. Or sorry, D19. Okay, and all we're doing here is telling Excel to estimate the equation with that price, with the price in the data. So here's the relationship that we estimated. This intercept plus this slope times this x, and the x is price. And so we're just plugging in the different prices to get the predicted demand. Given these prices, where would that fall in this curve or this graph? Okay. So it's intercept plus the slope times the price. And that's the predicted demand for the first linear. Enter. Alright, so you should get something 51.74. Now let's put in the equation for the power, which is this next equation. Equals $$B, $22 times B4 raised $B, $23. Okay, so in cell F19, type in equals $B, $22 times B4 raised to $B, $23. So we're just typing in the equation for the power fit, okay, which is the coefficient, the constant times the x value, which is the first price, and raised to the exponent of negative 1.91. Alright, so based on this price, where does this prediction fall on the curve over here? So if the price is 450, this number, this output will give us where we fall on the curve. So if you hit enter, 50.24.
Did you show the linear, the equation for the linear prediction? I got a completely different number than 51.
Yeah, so here you go. It's equals, and make sure it's it's highlighting the cells. So you can double check when it's highlighting the right one. So it's equal, and the dollar signs well, it won't matter right now, but equals $B, $19 plus $B, $20, and then times B4. And that B4 should pull in the first price of 450.
Yeah, I see what I did. I typed in the slope wrong.
Oh yeah, that'll do it.
Thank you.
Okay, did you get the 51.74?
Yes, I did.
Okay. Alright, so we got that, we got the power, and then we got one more, and then after we get this one in, we can apply the formulas down, so once we type them in appropriately, we don't have to type them in again. Create an exponential, last equation. Equals $B, $25 times EXP. That's the exponential reference in Excel. And in parentheses, $B, $26 times B4. And so this goes in cell G19 equals $B, $25 times EXP. Alright, so it'll choose the formula in Excel, EXP, and then in parentheses, type in the rest of that equation. $B, $26 times B4. Alright, so see how it's choosing the parameters for the exponential. All we're doing again is typing in the equation that we got for the exponentials, putting in the data point for price, and then this will tell us where it comes on the curve. to the exponential. So if we put in 450, where would that give us on this curve over here? All right, and so that's, here's the constant times exp exponent, and that's raised to the exponent times the price of 450, and that gives us the prediction on the curve for the exponential of a demand of 49.17. All right, so you should see that, so these are the predictions. This is the actual demand, and so they're not going to be right on, but there should be somewhere around 45, and so they're all in the, 40, they're all around 50, so they're somewhat off of 45, but in the realm. So for the first one, that's the actual, when the price is this is demand, this was the prediction for demand for the linear, the prediction for demand for the power, and the prediction for demand for the exponential. Okay, and the next step is to apply these formulas and see what the predictions are for each of these prices. So when price is 300, 440, and so on, what's the prediction, or where does that fall in this curve, that curve, and then the exponential curve? And to do that, just select, if you got these equations, this one, and this one, the best way to do this is select them all together. Okay, select G19 to G19, and then just grab the bottom right corner and drag it down 11 more times until you get to the 12th data point of price. So just do this. 1, 2, 3, 4, 5, 6, 7. Oh. Okay, if you drag it down and apply these formulas to the range of E19 to G30, that should get all the predictions for all the three different equations for the actual prices, and these are the predicted demand. So you can see the last column in 30, it takes the price from month 12 of 390 and gives us the prediction for the linear curve. For the exponential, for the power curve, and for the exponential curve. So you should, if you did it correctly, you should notice that it's always taking from the appropriate parameters, but the data point for price is changing because you want to see when the price changes, where does that lie in these predicted curves, and we're trying to see which curve is closest to the actual data. Okay, so everybody following along here, do I need to go over everything on these steps? All right, where we go? All right, next step. Okay, we are going to now do some error measures and then see which of the equation types fits the data the best. And once we decide that, we'll use that to do the profit model in the next tab. All right, so step 7. is they calculate the APE, or the absolute percentage error for all the types. And so that's basically the percent off from the prediction versus the actual data. And so if the curve is closer to the actual data point, you'll get a small percentage error. If it's way off or farther off, you'll get a higher error. And so basically it's saying, like, this is the percent off the prediction was from the actual data, and that's just the absolute value of the difference over the actual. Okay, so let's go ahead and put in this equation in H19. So it's equal to the absolute value of $C4 minus E19 divided by $C4. Oh, you can't see this. Yeah, so there you go. So I think when I switch to look at the other screen, then it's, yeah, so you should be able to see it now. Okay, so here's step 7. And then here's the equation I just talked about, where we're trying to get the absolute percentage error, alright, the percent off, which is the difference divided and then over the original. Okay, so in H19, this is step 7. Let's put in this formula. Equals ABS $C4 minus E19 divided by $C4. Okay, so here we go. And H19 equals, alright, ABS, choose the formula for absolute value. Let's just take away the negative. Okay, and then the rest of the formula is $C4 minus E19. Alright, and then close the parenthesis, and then divide it by $C4. Okay, so you're going to apply the same equation to all the other ranges, so make sure you got it. It's equals ABS, and then in the parentheses, $C4 minus E19, and then divided by $C4. So the percent error is just the difference between these two, alright? So this minus this, and then divided by the actual demand. And so all we're telling you is what's the percent off that this is from this. And so you can see it's going to be like, I don't know, some 5% or something. 14%. Alright, so there you go. If that worked, and you got 14.98%, then what you can do is take the formula you wrote in for H19, that's going to be applied to the rest of this range, alright? And so if you're able to do this, we can just choose H19, that formula, drag it over here to J19, and then with those three selected, we can just drag it all the way down to get the rest of them, and that'll give, hopefully, the absolute percentage error for each of these. Just to grab this, drag it down. Okay, so for each of these predictions, this is how far off it was from the actual demand data. Yeah. And then down here where you see the MAPE, that's an acronym for mean absolute percentage error, and then all that means is the mean is average, so just average up all the absolute percentage errors for each equation type, and that's your MAPE. So in H32, the equation is equal to average of H19 to H30. Okay, so on average, the linear model was about 10% off. All right, so that means that this line missed the data, the actual data, by about 10%, and so in predicting demand is about 10% off. And then if you drag this average equation over to click on H32 and just drag it over there and there, this is the MAPE for the power, and this hopefully is the MAPE for the exponential. Alright, so calculating all the absolute percentage errors in the MAPE, did we get that step?
My percentages are just like a tad off.
That's probably fine. What do you have?
Like for the map, just so it's general, I got 9.59, 6.18, and 7.92.
Okay, yeah, that doesn't matter. That's close enough to get the correct result. Yeah, just leave it. Yeah, so don't worry about it. You got the same result that we got. We're just trying to see which one, type the lowest MAPE, and you still got the right ranking, so you can, I say just leave it.
Okay.
Okay, and so you'll see that, if you did this correctly, that we have some other error measures to compare, but, we're trying to see which ones fit the data the best, and technically that means which ones have the lowest error measures, and so this one was about 10% off, this one was about 7% off, and this one was about 6% off. So you can probably see that by default, just looking at this metric, that the power save had the lowest error, and given this criterion, we're going to select that one. So I'm going to just highlight the lowest MAPE, which is associated with the power, so we can confirm that that is the lowest. Okay, and then we got to do a couple more error measures to see if, so just looking at the MAPE, the power fit was the best one, but let's confirm, or let's double check. It could be that was just for this one. So let's do a couple more error measures, and particularly we're going to do the root mean square error, and we're also going to do the mean absolute error. All right, and so to do that in step 8, all right, so step 8 is to let's calculate the squared error. All right, so put this formula in K19. All right, and the squared error is just, it's a literal interpretation, so you take the error, the difference, and you square it. So take the difference between the prediction and the actual, and square it, and that's the squared error. So put this formula to do that. So K19, right there. The formula is equals, in parentheses, E19 minus $C4 raised to the 2. equals E19 minus $C4 raised to 2. And again, that's just, here's the actual demand, here's the prediction. So take the difference and square it, and that's by definition the squared error. Okay, if you get this equation, then that's the only equation you need, because Excel will apply it to the rest of the data and the rest of the types of equations. So if you get this equals E19 minus $C4 raised to 2, and K19, just take it, drag it over there to get the exponential and the power. So you have the range K19 and M19 selected, and we're going to do the same thing. We're going to take this whole range and drag it down like that, and that should hopefully calculate the squared error for all the different equations and then all the different observations. Alright, and we are, the thing we want, or the summary measure we want, is the root mean square error. So it sounds fancy, but it's just the square root of the mean of the squared error. So we need to take the average of this, and then square root it, and then that's the root mean squared error. Right? The square root of the mean of the squared error. So to do that, in K32, here's the equation, equals. Okay, the SQRT function will take the square root, and then in the parentheses you want to take the average. So SQRT in parentheses average, and then take the average of this range, which is K19 to K30, and then I think you want to close this parenthesis, and then one more. Okay, so you got, in the inside you got the average of the area, K19 to K30, and then the outside you take the square root. So you want to take the square root of the average. Alright, equals SQRT in parentheses average, and those parentheses, K19 to K30, and then a double parenthesis at the end. We get 7.72. And you can probably guess that we're going to take this formula in K32 and drag it over here to get the power, RMSE, and then over here to get the exponential, root mean square error. So this one does it for the power, and this one does it for the exponential. And then if we got the same results as I did, we'd see that here's the linear squared error, root mean squared error, here's the exponential. But the lowest one, the lowest error, again, would be the power fit. So I'll go ahead and highlight this, the lowest error here, to denote the power fit beats for is this lowest error for this criteria as well. Alright, so the squared error, the root mean squared error, do we good on this? Alright, so we have one more type of error to look at. Alright, so far we've decided that the power fit is the best, or fits the data the best given these two metrics. Let's finish the analysis and look at the absolute error. Okay, so we're still in step 8, and the absolute error is pretty simple. It's just the absolute value of the error. Alright, so actual minus predicted, just take the absolute value. Okay, so in N19, put in this formula. So there's N19, here's the formula. Equals ABS in parentheses E19 minus $ C4. Okay, equals absolute value equals ABS E19 minus $ C4, and what that does is, you're just taking the difference, alright, this minus this, and then take the absolute value, so with the negative, it just removes the negative. Okay, if you got that equation there, in N19 equals ABS in parentheses E19 minus $ C4, you know what's coming, you can take it, drag it over to power and exponential, and then with this range selected, N19 is P19, take the bottom right corner and drag it down to all of the rest of the calculations for absolute percentage error. There you go, so you should get all these for a linear, power, and exponential. And then the MAE is the mean absolute error, and that's just simply the average of the absolute error. So in N32 equals average of this area, N19 to N30, enter, and then you want to get the average, the MAE for this and this, and so just take N32 and drag it over like that, and like that, and this should be the MAE for the power, and this should be the MAE for the exponential. Okay, and this one was close, but you can see that the lowest, this is 6.110, this is 4.84, and again the lowest MAE is the power, so we'll select that one again, and given all the error metrics, the lowest error, the one that seems to fit the data the best, is the power set, and so when we do the profit model, we're going to select that, and so if you look at the graph, I mean, it does look like the best one, right, so this, here's the linear. Here's the power, and that looks like a pretty good fit, right? Most of the lines, most of the dots are pretty close to that line. And then the exponential doesn't look that either, but I think it's, we've determined, at least doing this analysis, that we're going to choose the power fit. Okay, so when we estimate, when you're trying to maximize profit, when we try to estimate demand, we're going to use this equation because that seems to be, given the historical data, the best fitting curve. Alright, and so that's the one we're going to use on the next tab. Alright, did everybody get all the error measures? Okay, great. So let's see what we're okay, so this is kind of a two-step exercise. And so the first step was to find the best fitting curve, which we did. The second step is to use that equation to maximize profit and do some analysis with the golf clubs and the cost changing. And so this is usually we don't finish this in one day. So let me summarize a few things. But we're gonna finish this next time because we're not gonna have time to do the whole second tab profit model. And so we're gonna stop here in a minute after step 8. And so if you go back to the tab, or go back to the spreadsheet, we've done the first estimation tab. We still have to do this whole profit model. There's no way we can do that in 10 minutes. So what we're going to do is I want you guys to save this, and if you can save it and have it ready for next Thursday, we'll start right off with the profit model. And so we still have another little bit to go here. We're going to use what we found here to maximize profit and do some analysis. So for this exercise, just save it somewhere. Save it to your flash drive or your cloud or whatever. And then have it ready for Thursday morning. And we'll start here with the profit model because there's no way we're going to finish this today. It's already 10 o'clock. Okay, so let me summarize. If you came a little bit late, just all right, so again, the first 4 assignments, including this one, are not going to be due until next Tuesday. So, for example, 2.2, 2.4, 2.5, which we're doing today, and finishing Thursday, and then the curve fitting assignment. So all the first 4 assignments that will finish up Thursday, nothing is officially due until next Tuesday because we've had some late additions, and some people need to get Excel still. And again, I showed you guys earlier, and if you don't have Excel, the full version, you can get it through the university by clicking on this link and putting in your email address. And Laverne has a contract with Microsoft, so you should be able to get Microsoft Office Student for all of Laverne students. So let me know if you have any questions on that. Nothing's due officially until next Tuesday, September 15th. So if you've done the exercises, you might as well turn them in. And so what we'll do Thursday Okay, what we'll do Thursday is we'll finish example 2.5 that we started today. It's a longer one. So again, what we've got to at this point, save your Excel file, and then I have it ready for Thursday morning. We'll finish it, and then I have a little curve fitting assignment that we got to do as well. And so we'll finish this on Thursday. We'll do this on Thursday. And then all of these things are due September 15th. And then everything else will stick to the total. Okay, so let's do it. Alright, so I think that's gonna be it for today. We'll finish this exercise on Thursday, as well as the next one, and then yeah, if you have any questions on what's due, let me know. Everything goes to the discussion forum when you're done, and if you still have problems getting Microsoft Excel, then let me know about that. But if you're good to go, then come back with this spreadsheet. We'll do it on Thursday. Enjoy the rest of your day, and I'll see everyone Thursday morning, same time. So thank you, everyone.
Thank you, Professor.
Thank you.